The APAS independence was put together over a number of years by a diverse, outstanding team of engineers, artificial intelligence experts, image analysis experts, microbiologists, medical microbiologists, and mechanical engineers.
So I'm the Director of Research. I have oversight over all the technical work at LBT, so I'm in charge of the machine learning programs and the image analysis.
I'm the Scientific Director at LBT Innovations. I'm a clinical microbiologist of over 25 years experience.
Microbiologist with over 30 years experience in both clinical microbiology and also commercial microbiology.
The principal technology is really in the analysis. The analysis in APAS is based on a machine learning framework which takes annotations inputted by bench-reading microbiologists, and it then takes those annotations and tries to learn how to replicate them on unseen agar plates. The knowledge and skills of the microbiologists are being embedded in a piece of software which is then used to process plates in the field going forward.
But the APAS independence uses machine learning algorithms to interpret images of plates.
The key measurements that APAS takes are really around the enumeration of the amount of growth on the plate and the different types of colony that are detected on the plate.
As a plate enters the instrument through the carriers, the plate is then processed via the imaging station. An image is taken of the plate, it's analysed in about 4 to 6 seconds. An assessment of the significance of the growth on that plate is made in that time. The plate is then given a designation of whether it's actually significant or not, and then it's moved through the instrument into the appropriate area.
So the imaging system was actually one of the most difficult parts of the development of the entire system. I think it's probably the part of which we're most proud in some ways. It seems very simple, but it's actually a very challenging imaging situation. APAS takes 2 different images of every plate, so it takes a toplet image and a bottomlet image, emulating the process that a microbiologist would use in a typical laboratory. We work quite hard to make sure the imaging system doesn't have any moving parts, so it's very reliable, and it also has minimal contact with the agar plate, which means you've got a lower risk of cross-contamination than some other approaches. Really, the main thing we do to prevent contamination is just to not touch the plate very much. The plate is opened by the instrument at the last possible moment before it's imaged. The instrument makes very minimal contact with the dish, so contact between the machine and the plate is very minimal.
The first module we designed is the urine module. Most microbiology laboratories, that's the highest workflow in the laboratory. The reason being that many of them are negative, up to 70% of those are negative, so it's good to get those out of the workflow. We're also working on at the moment the MRSA module, which is, again, a lot of those are negative, up to 95% can be negative, so they can take a lot of those out of the workflow. Down the track, we're also working on modules for different regions. For MRSA, different plates are used in different regions, and so we're trying to cover all of those. We've got some coming in from the US, we've got some coming in from England and France, so we're going to be looking at those in the very near future as well.
The APAS independence will free up microbiology time.
Because APAS is a Class 2 medical device, it has to be very controlled. There's a lot of effort put into APAS to make sure that the results are very consistent, both across plates and through time.